Okay, well this module is going to be about basic diode circuits. We're going to look at just one circuit here that has one diode in it, 3 branches, kind of a simple circuit, but it's just to illustrate how to solve circuits that have diodes in it, and we'll also talk about what the circuit would have looked like if we would have made wrong assumptions and whatnot. So the first thing that we have to do whenever we look at a circuit like this is we have to make an assumption about this diode. Is it forward biased or reverse biased? And forward bias, remember the definition of forward bias is that current's going to flow through it, and it has to flow through that direction from anode to cathode. So I'm going to assume that it's forward bias. It's pretty obvious in this one actually. We have 5 volts here. That's the only power supply in the circuit, and the current's going to be flowing that way. So most likely that's going to be forward biased. So we'll say forward biased, and now we need to start solving the circuit. We solve the circuit. And what we're going to be looking for is to in order to determine if our assumption is right, if it really is forward biased, we need to be looking to see if the current really does flow that way. And how do we know if it's going to flow that way? Well, we're going to assume that it flows that way, and then if we get a positive number for this current, that means that it really is flowing that direction. If we get a negative number, that means that the current's flowing that way, and that's impossible in this circuit, and so you made a wrong assumption. Scratch everything and start all over. So let's say for now we have forward biased here, and so we're going to have current going that way. We'll assume we'll have current that way and current this way. So we have I1, I2, and I3. And so we're going to do Kirchhoff's current laws and solve this circuit using Kirchhoff's current laws, and there's 4 equations. One is the Kirchhoff's current law equation, which is the currents going into the node equal the currents leaving the node, so it's I1 equals I2 plus I3. And after that, we can make an equation for each one of those things. Assuming we knew the voltage right here, we don't, so we're just going to name it a variable. We'll call it Vn, is what we usually do. We'll say I1 equals 5 minus Vn. That's the voltage drop across this resistor, divided by that resistance, 1 kilo ohm, and that's I1. I2 is going to be the voltage drop across this, which is Vn minus 0, or just Vn, divided by 2K. And then I3 is going to be Vn minus, well, if this is forward bias, one of the things that means is that the anode side will be 5.7 volts higher than the cathode side. So we know this is 0 because it's ground, and that means that this has to be 0.7 volts. And we can write that like this. We can just say Vn minus 0.7 divided by 3K. That's the voltage drop across here. Vn is 0.7, that's the voltage drop, divided by 3K. That's the resistance. And then we just plug all 3 of these back into this one and solve. Do a little algebra. So we have 5 minus Vn 1K equals Vn 2K plus I said V and wrote a W, Vn minus 0.7 over 3K. Now I'm just going to divide through by 1K over everything, and we're going to end up with 5 minus Vn is equal to 1/2 Vn plus 1/3 Vn minus 0.7 divided by 3. Okay, and now continuing on, we're going to continue doing our algebra here, and that's all this is just algebra. We've set up the equations, and now you just have to remember all your algebraic rules and whatnot, and you can solve the circuits pretty straightforward. So we're trying to get Vn by itself, so I'm going to add a Vn over here, and I'm going to take this over here, so I'm going to say 5 plus 0.7 over 3 is equal to Vn, and I'm going to gather terms. I'm going to have the 1/2 from here plus 1/3 from here, plus the 1 from here, and there we go. So the final answer is 5 plus 0.7 over 3 divided by 1 plus 1/2 plus 1/3. And that equals to Bn. Plug that all into a calculator, and we should get something that is roughly what, it's 2.815 or something like that. Let me do it on the calculator here, and we'll just find out real quick. It's 0.7 divided by 3 plus 5 divided by 1 plus 0.5 plus 1 divided by 3, 2.85, we'll say. So that is equal to 2.85, and that's Bn. Now we just have to plug that back into our circuit, or to our equations here, these three equations, to find out what I1 is. So we have 5 minus 2.85, and that is going to be divided by 1 kilo-ohm, so that's going to be equal to 2.15 milliamps, and this one is going to be 1.47 or 1.43 milliamps, and this one will be minus 0.7 divided by 3, 0.718 milliamps. And so we found all of our currents. We can note that there's no negative signs there, and so we have the proper circuit. Again, if we would have had a negative sign on this one, we would have known that we made the wrong assumption, and we would have had to start over. Alright, on the next one, maybe we'll do one that is in the wrong direction, is reverse bias, but we're going to assume it's forward bias, and we can see how that works.